Adding and subtracting polynomial expressions. In this video, you will see examples of expressions being added and subtracted and combining like terms. Here are our steps for adding and subtracting polynomials. Use the distributive property to clear parentheses, and then combine like terms. Remember that in like terms, the variables must be the same and raised to the same power to be like terms. When we combine like terms, we combine the coefficients, but we do not change the exponents. Let's look at number 1. I see two expressions with 3 terms each that are being added. I look between the parentheses to see that this is an addition problem. Since this is an addition problem and there's no coefficient, these parentheses aren't doing anything. It's the same thing as if I were to distribute a positive 1 here. So I could choose to rewrite the problem or cross them out, or look for my like terms right now. You may use different strategies to mark your like terms. Some students circle or make boxes or triangles around like terms. Some people highlight in different colors. And if I'm writing in a pencil, I typically look for like terms and I use the same underline for them. So 2x to the 4th and negative x to the 4th are like terms because they both have x to the 4th power. I also notice that I have 2 constants, which are also like terms. My 5x squared and my 3x to the 5th don't have any like terms with them, so those will still remain in my final answer. I'm going to go across and combine my like terms. 2x to the 4th combined with negative 1x to the 4th gives me positive 1x to the 4th. Then I have a plus 5x squared. I'll add my 9 with my 5 to get 14, and I still have 3x to the 5th. When we write polynomials, we typically write them in descending order by their degree or their exponent. That means that my first term is going to have the x to the 5th, then x to the 4th. I don't have any terms with x to the 3rd, so then I'll have an x squared. I don't have any terms with x, so I'll end with my constant, like this. So my answer is 3x to the 5th plus x to the 4th plus 5x squared plus 14. I did not need to write the 1 in front of the x to the 4th. Let's do number 2. In number 2, we see that we have a minus between the 2 sets of parentheses, so this is a subtraction problem. This means that I am distributing the negative, or the negative 1, to every single term in the second set of parentheses. I'm going to rewrite the problem with doing that. So I have 8x to the 5th plus 3x squared minus x to the 5th plus 2x squared minus 11. Since I was distributing a negative 1, the sign of every single term in this set of parentheses changed. Now I'll go across and combine my like terms. So I'll underline as I go, which is how I typically work from left to right. So I see 8x to the 5th, and I look across to see if there are any other terms with x to the 5th, which there is. 8x to the 5th minus x to the 5th, or minus 1x to the 5th, is 7x to the 5th. Then I see 3x squared, which is a like term, with 2x squared. Together, that makes 5x squared. And then the 11, or the constant, is on its own. This is already in the correct order because I have my biggest exponent, then my middle, then my exponent of 0 if I were to write x to the 0 there, or just my constant. If your page says classify, this means that we're going to name the polynomial by the degree, or the exponent, and the number of terms. You can refer back to your notes for this vocabulary. In this case, we have x to the 5th, which means that we have a quintic, and then the polynomial has more than 3 terms, so we don't have a special name, so we'll just call it a polynomial. In the next problem, we again have a quintic, because it's x to the 5th as our highest degree. But this time, since we have 3 terms, we're going to call this a trinomial. Remember, we have monomial, binomial, trinomial, and these are all examples of polynomials. In the next example, I see that we have coefficients outside of the parentheses, so I know that I'm going to be distributing a number other than just a negative 1 or a 1. So the first step is to multiply every term in the first set of parentheses by 6, and every term in the second set of parentheses by 2. This gives us 12x to the 3rd plus 6x minus 48 plus 6x to the 4th minus 12x to the 3rd plus 2. Now I'll look for my like terms, again using any strategy to mark them. So I'm going to go from left to right, making sure I don't forget any terms. First, I have 12x to the third, which I see combines with the other x to the third, negative 12x to the third. These actually cancel because 12 and negative 12 are opposites of each other, and they're additive inverses. My next term is 6x, so I'll look across with my finger, and I'll see that there aren't any other terms that I can combine with 6x, so I'll write 6x on the next line. Then I see negative 48, which is a like term with 2, so I get minus 46. And my last term is 6x to the fourth, which doesn't have any like terms, so it stays in my answer. My final step is to rewrite this so that the exponents are going in descending order. So 6x to the fourth plus 6x minus 46. Notice that in this one, I actually underlined with different underlines all the way across. This is a great strategy if you're someone that often loses some of your terms rather than not underlining terms that do not have a like term pair. Let's classify this. We have an x to the fourth as our degree, so this is quartic. And again, since there are 3 terms, we have trinomial. I want to point out in the next example how we have a minus and a 4. This means that we're doing a subtraction problem. In other words, we're distributing the negative 4 to each term. Whenever you distribute, that gets rid of the parentheses. Notice how when I rewrote this problem here, there aren't any parentheses left. That's important as we move into other problems where parentheses end up showing us to multiply. This concludes the required part of this video. If you're someone that knows it would be helpful to see 2 more examples, then please keep watching. Example 4. In example 4, I'm going to be distributing the coefficient 5 and the coefficient negative 4. I'll underline what I'm distributing to remind myself that the sign goes with it. 5 times 2x squared gives me 10x squared. I multiply the coefficients. 5 times x to the third, really I'm multiplying the 5 with the 1, so that gives me 5x to the third. Now I'll distribute negative 4. Negative 4 times 6 gives me negative 24, so this is negative 24x to the third. And negative 4 times negative 3 gives me positive 12, so plus 12x squared. I'll look across for my like terms. 10x squared and 12x squared are like terms, so when I add 10 plus 12, I get 22x squared. 5x to the third and negative 24x to the third are like terms, and when I add them together, I get negative 19x to the third. My final step is to rewrite these in the proper order. Remember to keep your signs with your numbers. So if it's negative 19, the negative stays with the 19. This has a degree of 3 because it's x to the third, so this is cubic, just like when we have something cubed. And it has 2 terms, so it is a binomial. Let's look at the final example. It says write an expression for the amount of fencing that is needed to build a fence around the trapezoidal yard shown here. This is a trapezoid because it has 4 sides, so it's a quadrilateral, and I have 2 pairs of parallel sides. To find an expression for the amount of fencing, I know that I need to add the 4 sides together. Some people like to do this in their head, or you could write out an expression with these 4 expressions added together. So starting at the top and working around, we have 2x plus 3x minus 1 plus 6x minus 8 plus 4x plus 5. I'll look for my like terms. This time I'll use different colors to show you that strategy. So I could underline or highlight all of the terms with the x, and then underline or highlight in a different color all of the constants. 2x plus 3x is 5x, plus 6x is 11x, plus 4x is 15x. Negative 1 combined with negative 8 is negative 9, plus positive 5 gives me negative 4. So my expression is 15x minus 4. There aren't any units, so I don't need to include them here. Thank you for watching.